periodic table. That's one of the things that we know already. We know that molar mass is often written as a big capital M or two capital M's. I prefer the two capital M's because one capital M we're going to use for molarity at the end of this unit. And we know that molar mass has the combined unit, grams per mole. That -1, again, remember, means it is on the denominator. So it's grams divided by moles, grams over moles. We know that calculations from mass to moles or moles to mass involves the masses from the periodic table. So these are all things that we've already successfully completed this year. Okay, so using that knowledge, let's do a problem. We want to know how many moles are in 42.00 grams of dihydrogen dioxide. So one of our old skills is to identify the compound symbol. So take a minute on your paper, write down what symbol dihydrogen dioxide would have. Give me a thumbs up if this is what you got, H2O2. Thumbs down if you didn't. Okay, remember, since it's not ionic, we can't reduce it. It's H2O2. Excellent. So we always want to write out the givens and what we want. And at this stage of the game, it's like, why are we bothering to do that? Well, we're bothering to do it to get into the habit because you're going to need to the more complex it gets. So I am given 42.00 grams of H2O2, and I want moles of H2O2. I'm going to need a molar mass, and I need the molar mass of H2O2, so I'm going to put out need. I need molar mass of H2O2, and I calculate that now by looking at the periodic table. So hydrogen, there's 2 of them, and each of them weighs 1.01 grams per mole. That's what my periodic table tells me. And I also have 2 oxygens, so I'm going to add 2 times the mass of oxygen from the periodic table. So I look at my periodic table and I see that oxygen has a mass of 16. 2.02 plus 32 gives me 34.02 grams per mole. That's my molar mass of dihydrogen dioxide. I was going to say hydrogen peroxide, which is the common name of dihydrogen dioxide. Now I can set up my conversion. The general form is always you put what your given is first, and then you set up a fraction or multiple fractions, depending on how many you have, of ratios. Now my ratio that I'm going to use on my fraction is right here. The 34.02 grams is for every 1 mole. In that fraction, I have to identify what I want to get rid of and what I want. What I want to get rid of goes on the bottom of my fraction, so in the denominator. What I want goes on the top of my fraction, the numerator. So what is it that I want to get rid of? Grams, absolutely. So I'm going to put 34.02 grams of H2O2 on the bottom and 1 mole of H2O2 on the top. So I set it up just like this. 42.00 grams of H2O2 gets multiplied by my ratio, 1 mole of H2O2 per 32.02 grams of H2O2. What's the question? Yes. It was the beginning of stoichiometry. We hadn't really gotten into the stoichiometry part of it yet. It's just a conversion. Okay, multiply everything that's on the top, divide by everything that's on the bottom. Do that on your calculators now, please. My grams of H2O2 cancel out. I'm going to be left with moles of H2O2. Give me a thumbs up if my number is going to be greater than 1, and a thumbs down if my number is going to be less than 1. That's one trick for you on multiple choice sections of the exam. We've seen it before where like all of the answers except for 1 is the wrong thing. They're all below 1. This should be above 1, so thank you for giving me thumbs up. This should be above 1 because 42 is greater than 34. So that's a quick way if you have a multiple choice question to rule some out right away, or sometimes to get to the right answer like we've seen on previous exams.
42 is supposed to be on top then?
Yes, so we'd multiply 42 by 1 and then divide by 34.02.
It looks like it's off to the side.
It is slightly.
Oh, alright, that's where the ground
Yep.
is. But when you multiply grams by moles, would that be 42?
Yep, exactly.
Would that just convert to moles?
Yes.
Oh, because the grams cancel.
Yep,
Right.
exactly. So we should get 1.235 moles with the correct number of sig figs even. So I have 4 significant digits in 42.00, so I need 42 or 4 significant digits in my number. Yes.
1.235.
Yep, 1.235. Okay, here's another reminder for us. We did gas laws already this year as well. And at one point we said that for a gas, the number of moles is equivalent to this equation. So moles, which we represent with an N in an equation, but that's not the unit. Some of you have been writing the unit as N. That's not the unit for it. That's the symbol that we use in an equation to represent it before we put in our numbers. The unit for moles is MOL. So my number of moles is equal to the volume of whatever my container is divided by the molar volume, where the molar gas volume at standard temperature and pressure, STP, remember, standard temperature and pressure, is 22.4 decimeters cubed. Now, if you don't remember what standard temperature and pressure represents, what that temperature and pressure is, look back at your chapter. If you look at it, there's a big box with a key on it because it's one of the key things to remember. It's your little tip there as you're looking through the textbook. Find those things with keys. Make sure you remember them. This is one of those things. STP is 22.4 decimeters cubed, and you can figure out what the specifics are for STP in your book. And the molar gas volume at RTP, room temperature and pressure, is 24 decimeters cubed. So to figure out moles, all I have to do is take my volume of the container and divide by either 22.4 or 24, depending on which one we're given, RTP or STP.
So then the 34.02 in the equation above, figuring out would be the molar volume.
No, the molar volume are these two numbers. Yep, that would be the molar mass. Yep. This is specifically dealing with gases. Good question. Okay, so let's say we have a balloon that is filled to 2 liters with nitrogen gas at standard temperature and pressure. How many grams of nitrogen are present? So it's not just asking for moles, it's actually asking for mass. So this is going to take 2 steps. First thing we're going to do is solve for moles. Then we're going to convert those moles using the molar mass to grams. So what is my V in this equation? 2, very nice. And then I look at my V molar of STP. What is that?
22.4.
Nice, 22.4. So my moles, my N value, my moles, is equal to 2 divided by 22.4. So I have 0.09 moles of N2. That's my first step. Now I have to do what I did in my first problem and figure out the molar mass of N2. So I look at my diatomic molecule, nitrogen, one of them is 14.01, but it's a diatomic molecule. It's one of those magical 7s. So I have, 28.02. Beautiful. I start out with my given. My given here is 0.09 moles. And I multiply that by 28.02 grams for every 1 mole of N2. From the mass of nitrogen on the periodic table, each nitrogen is 14.01, but I have 2 of them, so it's 2 times 14.01. That would be 28.02.
How'd you get into?
Because it's a diatomic. Nitrogen on its own is always diatomic, and it tells me in the problem that it's nitrogen. You get some number 2 point something 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 something, but my first value was 2 liters. That means I need 1 sig fig, so 3. It rounds up to 3. Still see a few pens going. I'm going to leave it on this one a little while longer. Okay. So, if you flip the page, this won't look so overwhelming. So most of it's written for you already. You just have to fill it in. So the coefficients of a balanced equation tell us how many moles